We want to obtain the general pattern for obtaining sum, a better approach to obtaining sum and product of roots. In this case, without knowing the roots. You don't need to know alpha, the value of alpha and the value of beta before you get the sum and product of the roots. We recall from our first video that a quadratic equation in x would take this form: ax squared plus bx plus c equal to 0, where a, b, c are constants. A, B, C can be any numbers, but A must not be 0. Of course, if A is 0, this reduces to a linear equation. So if you have a quadratic equation in x, ax squared plus bx plus c, I want to call this equation 1 for the purpose of this section. You will also recall that if alpha, beta are the roots of any quadratic equation, if alpha, beta are the roots of the quadratic equation above, recall, if alpha, beta are the roots of a quadratic equation like this, then we have the quadratic equation as x squared minus alpha plus beta x plus alpha beta equal to 0. This is the one I will call equation 2. My equation 1 is the general form of a quadratic equation in x. My equation 2 is the general form of a quadratic equation when you are given their roots as alpha, beta. Let's proceed. We make equation 1 to look like equation 2. Let's make equation 1 to look like equation 2. That means I want A to be 1. I want A to be 1. I have x squared, ax squared in equation 1, and I have only x squared in equation 2. The coefficient of x squared in equation 2 is 1. The coefficient of x squared in equation 1 is A. So I need to make the coefficient of x squared in equation 1 to be 1. Now we take this, divide equation 1 by A. We divide by A so that equation 1 would be compared to equation 2. That will give us x squared. If I divide equation 1 by A, remember equation 1 is ax squared plus bx plus c equal to 0. So if I divide by A, I'll be having over A, here over A, here over A, here over A. This will produce x squared. This will produce plus b over ax. This will produce c over a. And this will produce 0. Permit me to call this equation 3. I have equation 1, equation 2, equation 3. Of course, I got equation 3 from equation 1. I just called it equation 3 for easy understanding. Alright, we have 2 and 3. We now compare equations. Compare equations 2 and 3. Compare equations 2 and 3. If we compare these two equations, look at equation 2, look at equation 3. If we look at these two, you would notice that x squared, the term in x squared is the term in x squared. So that is not a problem. They are the same thing. And comparing this term, for this to be equal to this, x squared is equal to x squared. For the coefficient of x in equation 1 and the coefficient of x in equation 2, we notice that minus alpha plus beta, which is the coefficient of x in equation 2, is equal to b over a. It implies that alpha plus beta is equal to, if this negative comes here, minus b over a. Please do not forget this first one. If I compare the constant terms, comparing the constant terms, we'll have alpha beta is equal to c over a. Do not forget this. It means whenever you are given a quadratic equation, like equation 1, and you are asked to find the sum of the roots, you don't need to get to know the roots. You don't need to know the value of alpha and the value of beta before you find the roots. Only the coefficients in the equation will give you the sum of the roots and also give you the product of the roots. Sum of roots is minus b over a. Product of roots is c over a, where a is the coefficient of x squared, b is the coefficient of x, and c is a constant in the equation. Once you put a, b, c where they should, you will get the sum and product of roots of an equation. Remember, without knowing what alpha is and what beta is. We resolve the two equations we did earlier, and the first one, find the sum and product of the roots of the equation x squared plus 7x plus 10 equal to 0. If you are asked this question, you do not need to solve it to obtain the roots. Just use this approach. I will take the two examples and I'm sure you will enjoy it.